Good morning, everyone. Welcome to the first topic in the information retrieval series. Today's topic is about what information retrieval really means in the modern times and why this quest to organize the collective information of humanity has been evergreen, and how that quest has been answered differently at different points in time, depending on the technologies and ideas which were prevalent during that time. Let's dive in. So what is information retrieval? At its core, the smart folks at Google and IBM, they define it as finding unstructured data. This could be free text in documents, images, video, code, not really the neat rows you would see in the database. And this is within a huge collection of such unstructured data, and you want to find information that satisfies a specific information need. And this is pretty challenging. Because this is like the classic needle in a haystack problem. Imagine a haystack is the entire internet along with all this private information which is bundled inside the companies, and these are pretty challenging in three different ways. So there is volume. There are already like 200 zettabytes of data. Now, to put this in perspective, an email which just says, hey, are we meeting at 5 p.m. translates to 1 kilobyte of data. And if you consider 1 kilobyte to be 1 cup of water, 200 zettabytes, which is the size of the internet as it stands today, is the size of the Pacific Ocean. And add to this the velocity of data that is getting added into it. To 200 zettabytes, you're adding 0.4 zettabytes of data every single day. And this is not just your single like text information. This is a variety of information like web pages and audio and videos and emails, social media, scientific data, sensor information coming from your cameras, etc. And the biggest amount of data in this is actually 50% of the content. More than 50% of the content is actually videos that is getting sent through the global traffic channels. And this is the haystack. Next comes the needle, like what are you looking for within this? And you may not even exactly know what this needle looks like. It could just be a vague idea or an information need, and that's really where the challenge in IR is. So how does this all really work? Now we'll dive deeper as we go through the rest of the topics later in this series, but the first is really to get super smart map of this very hazy haystack, and we're going to call this indexing. And then making it ready for asking questions. You can ask questions like, hey, find me needles that look kind of like this. And this is what querying looks like. And finally, you just don't want all the needles. You really want the best, most relevant ones to the question you are asking. So that's a very crucial part of the information retrieval story, and that's called ranking. So functionally, relevance is really the key in information retrieval. But similar to like a database query, like get me all the users in California, you don't want all the users, you really want the one user who you really care about. So information retrieval relevance is about not getting the irrelevant results at the top, which we call false positives. And then there are missing good ones, which we would call as false negatives. And along with this, there are competing priorities to relevance as well. Now you want to get ads into your set of results, and you want to optimize for like secondary objectives like diversity in the results, variety in the results, etc., which are all competing with the relevance equation. But then there are these non-functional aspects as well. Like it's not about just getting the right results to the user, it's also getting back really fast, like 100 milliseconds or at least 500 milliseconds, right? And you need to optimize for cost you are taking to answer each of these questions. Then there is securing the data, then handling the user-generated content with the privacy expectations, and using those data judicially as we show it to other users. You put everything together, we have this cross-cutting, super relevant, and complex problem whose ecosystem is also changing rapidly thanks to the latest artificial intelligence breakthroughs. You put all of them together, it's just a fascinating puzzle.